All right, we're going to begin Lesson 8, which is about representing proportional relationships with equations. I thank you for paying attention to the substitute in the room today and making sure that you're abiding by and enforcing the social contract that we all agreed upon. I hope you all had a wonderful long weekend, and I look forward to seeing you all on Thursday. Today's lesson, the essential question is about how can unit rate be used to write an equation relating two variables that are proportional. So we've spent a lot of time talking about how to determine whether or not two quantities are proportional from a table and then from a graph. Well, now we're going to learn how to write an equation that describes a proportional relationship. And before we get started on doing that, let's think about what we already know. So what do we already know about calculating the constant of proportionality? You'll find this exercise, this classwork, on page 2 of your packet, so you want to make sure you have that open so that you can copy down what I have on this video. So what we already know about calculating the constant of proportionality is that thing that I tell you to do every time. I've drilled it into your head. You take y and you divide it by x. When you take y divided by x, you're finding that unit rate, that constant of proportionality, or that common multiplier that determines whether or not your relationship is proportional. And for some reason, they decided to give a letter for that constant of proportionality, and that letter is k. I don't know why they didn't choose c or anything like that, but they chose k. So we know that the k, or the constant of proportionality, is found by taking y divided by x. So let's think about how we can use that to write an equation. And our goal when we're writing an equation is to get it into y equals form. So we want it y equals something. Now I'm not expecting you to completely understand what I'm doing, but I want you to write it down and I want you to follow along with my explanation. See if you can figure it out. Okay, so we're going to rewrite everything except that I'm going to do a little math magic here. Our goal is to isolate y, or to get y all by itself. And in order to do that, I have to get rid of this divided by x. Now, if you remember solving equations from last year, to undo an operation, you have to do the inverse operation. So the opposite of division is multiplication. So I'm going to multiply both sides by x. And when I do that, those two x's are going to cancel out. So I have this x times k equals y. Well, that's totally fine to write it like that, but typically people like to have it in the y equals equation. I'm going to use my reflexive property and go ahead and write it completely mirrored across the equal sign. And it's going to be y equals kx. Y equals kx. This is how we're going to write an equation for all of our proportional relationships. And it's super easy. All you have to do is find that constant of proportionality, which we know how to do anyway. You take your y divided by x, and then when you find that number, when you find that constant, you're just going to plug it in right here for k and keep the y and the x the same. So super, super easy. Now remember, what I want you to remember about these different parts of this equation is that y represents any of your, so let's go through actually real quick and define them. So we'll start with k. K is your constant, or your proportionality. So constant of proportionality. That's what you find y divided by x for. We also call this our unit rate. And then x in the equation represents our x values, or on our graph it would be our x coordinate. And then y in the equation represents our y value, or on our graph, our y coordinate. we'll discuss what this means a little bit more in detail in the upcoming exercise. So here's a real life situation that I'm sure you've found yourself in. I know that I've found myself in this situation. And it's about, do we have enough gas to make it to the gas station? So your mother has accelerated onto the interstate beginning a long road trip, and you notice that the low fuel light is on, indicating that there is half a gallon left in the gas tank. The nearest gas station is 26 miles away. Your mother keeps a log where she records the mileage and the number of gallons purchased each time she fills up the tank. Use the information in the table below to determine whether you will make it to the gas station before the gas runs out. You know that if you can determine the amount of gas that her car consumes in a particular number of miles, which is called our fuel economy, or MPGs, then you can determine whether or not you can make it to the next gas station. So here's the record. You have gallons, 8 gallons, 10 gallons, 4 gallons, miles driven, 224 miles, 280 miles, and 112 miles respectively. So remember that when we were building our tables, we made a conscious effort to determine which variable or which quantity was going to represent our independent variable and which one was going to represent our dependent. And remember, the independent is the one that you actually have a choice on. In this case, you have a choice on how many gallons you put into your car, and that affects how many miles you can drive. So in this case, gallons would be our independent, or our X, and miles driven would be our dependent, or our Y. So at the top of page 3, I want you to write X is independent, and then Y is dependent. That's an important that's an important concept to remember. Alright, so what we need to do is we need to find the constant of proportionality and explain what it represents in the situation. So if you remember, the constant of proportionality is finding that K value, which is found when we take any Y value divided by X value. And we want to make sure that this relationship is proportional, so we're actually going to do this 3 different times. I'm going to first start off with 224 miles driven in 8 miles, and that would give me 28. Then I'm going to check for 280 miles driven divided by 10, which also gives me 28, and then 112 divided by 4, which also gives me 28. But remember, I need to think back to what those numbers actually mean. So 224 represented miles, 8 represented gallons, so 28 actually represents 28 miles per gallon. So when we explain this, when we write down our explanation, you're going to want to write that the car travels 28 miles for every gallon of gas, for every 1 gallon of gas. This is also known as 28 MPGs, miles per gallon. It's fairly decent fuel economy. Part B is asking us to write an equation that will relate the miles driven to the number of gallons of gas. So remember, our equation format is in the form y equals kx. Well, from part A, we already found our k. We found that it is 28 miles per gallon. So I'm going to plug that 28 in for k. And I have y equals 28x, which is a totally fine equation. There's nothing wrong with that, except that that y and that x has absolutely no meaning for the context because I don't remember what I'm talking about. So sometimes what we do is we change those y's and x's so it makes sense with what we're actually talking about. So if I look back up at my table, I see that I have miles driven for my y value. So what letter actually makes sense to use for y instead of y? I'm going to use M for miles. And on the other side, I've got X for gallons, and I'm going to use G instead. So a better equation, not that y equals 28x is wrong, it's just that I don't know what y is and I don't know what x is unless you define it. A better one would be M equals 28G. Using the letters M and G means I have a better chance at plugging in my numbers correctly. So if you look at this equation, what it means is to find the miles driven, I'm going to take 28 times the number of gallons of gas I have left. So for every gallon of gas I have left in the vehicle, I'm going to multiply that number by 28, and it's going to tell me how far I can go on that particular amount of gas. Part C is asking us, knowing that there is half a gallon left in the gas tank, when the light comes on, will she make it to the nearest gas station? Explain why or why not. We're going to think about this two different ways. One way, we're going to be using our new equation that we just found, M equals 28G, meaning miles left to drive is equal to 28 times the number of gallons I have. Well, half a gallon left, that's my G value. That's the gallons. So I'm going to plug in half, or 0.5, into my equation. And that just means I'm going to take 28 times 0.5, or think about what's half of 28. Well, half of 28 is 14 miles, because remember we're solving for M, and M represents miles. The other way to think about it is just to go ahead and think, well, if every gallon allows me to travel 28 miles, and I only have half of that, then I can only travel half as far. So half as far of 28 would be 14 miles. And my gas station, the closest one, is 26 miles. So no, she's not going to have enough gas. So the answer is no. She will not make it to the next gas station. She's only a little bit over halfway there. So no, she will not make it. Because she can only drive 14 miles. Part D is asking us to use the equation to determine how far your mother can travel on 18 gallons of gas. Alright, so here we got to figure out, it says solve the problem in two ways. I want you to go ahead and cancel that. Just scratch that. We're going to solve it one way. We're going to use our equation M equals 28G. Miles left to drive equals 28 times the number of gallons left in my car. So if she has 18 gallons of gas left, well, that's going to be my G value. So I'm going to plug that in. M equals 28 times G, which would be 18. And type that in your calculator and you find out that she can drive 504 miles. So the answer would be your mother can drive 504 miles with 18 gallons of gas. So using the equation found in part B, determine how many gallons of gas would be needed to travel 750 miles. This one's a little bit backwards. So you have miles equals 28 times G, and I have to figure out that I have 750 miles. Well, every other problem we've solved before has given us the gallons, and this one has miles. So it's actually M. I'm going to plug in 750 equals 28 times G. Well, from your knowledge of solving one-step equations from last year, you know you're going to have to do an inverse operation to get G all by itself. So to undo multiplication, you're going to divide both sides by 28. And that vinculum, that fraction bar, actually means division. So I'm going to cancel those 28 divided by 28. That simplifies to 1. 750 divided by 28 is 26 8/10 gallons. So 26.8 equals G. So the answer would be 26 8/10 gallons would be what you would need to have in your car in order to travel 750 miles without stopping. So the classwork we did at the beginning and this first exercise that we just wrapped up emphasized how we can write an equation for a proportional relationship. You need to remember that all proportional relationships can be written as an equation in the form y equals kx. And the only thing you really have to do to figure out what this equation is to take y divided by x to find your k, that constant of proportionality, which we've been doing since the very first lesson. And you just plug it in the spot where k is. We'll practice this more tomorrow, but your homework is to focus on the first 3 problems of this assignment. We'll eventually do all 6 problems, but for tonight I only want you to focus on the first 3. Tomorrow you'll go over that second exercise and finish up with the second half of the homework. All right, have a great evening, and I will see you Thursday.